You're listening to the N2K Space Network.
From phishing to ransomware, cyber threats are constant. But with NordLayer, your defense can be too. NordLayer brings together secure access and advanced threat protection in a single, seamless platform. It helps your team spot suspicious activity before it becomes a problem by blocking malicious links and scanning downloads in real time, preventing malware from reaching your network. It's quick to deploy, easy to scale, and built on zero trust principles, so only the right people get access to the right resources. Get 28% off on a yearly plan at nordlayer.com/cyberwiredaily with code cyberwire-28. That's nordlayer.com/cyberwiredaily, code cyberwire-28. That's valid through December 10th, 2025.
Today is November 20th, 2025. I'm Maria Varmazis, and this is T-Minus.
T-Minus. 20 seconds to LOS, T-Dress. Go for deploy. Roger, roll.
Interloon has been selected by AFWorks for a SBIR direct-to-phase 2 contract in the amount of $1.25 million.
4.
Via Space and Seagate Space are collaborating to develop an offshore launch capability for Via's Dauntless hybrid rocket.
3.
Axiom Space and KBR have completed the first uncrewed thermal vacuum test of the Axiom Extravehicular Mobility Unit pressure garment.
2.
Thales Alenia Space has signed multiple contracts, shaping the core industrial team that will build the European Space Agency Argonaut Lunar Descent Element.
1.
Katalyst Space has selected Northrop Grumman's Pegasus XL air-launched rocket to deliver its robotic spacecraft to orbit for the upcoming NASA Swift rescue mission.
0.
Our guest today is Derek Harris, Head of Business Development at Skyrora. We're going to be talking about their new contract with the European Space Agency for 3D printing. So stick around to find out more about that after today's intelligence briefing. Happy Thursday, everybody. Thank you for joining me today. First up, a robotic rescue mission set to make history and scheduled to launch next year will fly on a rocket dropped from a plane to rescue a falling NASA telescope. And no, they have not resurrected Virgin Orbit, and no, that telescope isn't the Hubble. Katalyst Space Technologies has selected Northrop Grumman's Pegasus XL air-launched rocket to deliver its robotic spacecraft to orbit for the upcoming NASA Swift rescue mission. The $500 million Swift Observatory has been studying gamma-ray bursts from low Earth orbit for 2 decades, but its orbit has decayed considerably over the years. And as Swift gets lower and lower, it encounters more frictional drag from Earth's atmosphere, so its descent is accelerating. It is currently predicted to crash back to Earth by the end of 2026, and there is no replacement mission in the works. So NASA decided to fund a rescue effort, selecting Katalyst to lead the charge. Katalyst has under 8 months to get its Link spacecraft on orbit to rescue Swift. The Link spacecraft is a first-of-its-kind orbital servicing vehicle. Katalyst says that the Pegasus is the only system that can meet the orbit, timeline, and budget simultaneously. The mission aims to reposition NASA's long-lived Neil Gehrels Swift Observatory into a higher orbit to extend its scientific operations, and it is scheduled for launch in June 2026. And we wish them the absolute best of luck. Let's head on over to Europe now for our next story, and Thales Alenia Space has signed multiple contracts shaping the core industrial team that will build the European Space Agency Argonaut Lunar Descent Element. ESA's Argonaut mission, which is planned for launch from the 2030s, will deliver cargo, infrastructure, and scientific instruments to the moon's surface. These contracts follow the one that was already signed between ESA and Thales Alenia Space in January 2025. It referred to the design, development, and delivery of the Lunar Descent Element, including responsibility for mission design and integration. As the prime contractor and system integrator of the Lunar Descent Element, Thales Alenia Space in Italy leads the industrial consortium that is responsible for the system, the entry, descent, and landing aspects, as well as the general and specific architecture of the thermomechanical, avionics, and software chains. The core industrial team is made up of Thales Alenia Space in Italy, Thales Alenia Space in France, Thales Alenia Space in the UK, as well as OHB System AG and NAMO, part of the consortium as strategic subcontractor for the propulsion. Axiom Space and KBR have completed the first uncrewed thermal vacuum test of the Axiom Extravehicular Mobility Unit pressure garment, also known as the AxEMU. The test evaluated the spacesuit's thermal performance and advanced materials in extreme temperatures at the vacuum of space. Axiom and KBR say that the test is a critical next step in collecting data on how the spacesuit will endure the harsh environment on the lunar South Pole during the Artemis 3 mission. The test was conducted inside the thermal vacuum chamber at KBR's Aerospace Environment Protection Lab in San Antonio, Texas. The Axiom Space EVA and KBR teams worked side by side to enable this integral test from concept to execution in less than 1 month. Via Space and Seagate Space are collaborating to develop an offshore launch capability for Via's Dauntless hybrid rocket. The partnership aims to unlock a new era of mobile sea-based launch infrastructure. It aims to expand access to space with greater flexibility and mission-specific orbit targeting. The Dauntless system supports both commercial and defense sector missions, and Via Space believes that it is compatible with Seagate Space's Gateway floating launch platform. This collaboration marks a major step towards mobile and distributed launch operations, hopefully freeing space access from the bottleneck of fixed land-based seaports. Seagate Space is currently pursuing third-party validation of their Gateway platform, which, once received, will make it the first such design to receive approval in principle under the American Bureau of Shipping's Offshore Spaceport Guidelines. Future launches and demonstrations, including a potential stage test of the Dauntless, will further the company's innovative leadership in the offshore launch arena. And T-Minus listeners might remember that I just interviewed Seagate Space co-founder and CEO Michael Anderson on our November 18th show. So go back and listen to that one if you want to learn more about Seagate Space, or we will drop a link in the show notes for you. And lunar mining company Interloon has been selected by AFWERX for a SBIR direct-to-phase 2 contract in the amount of $1.25 million. The contract focuses on new technology to separate helium-3 from domestic helium and increase the country's supply of this critical isotope. Now, helium-3 is essential for cooling superconducting quantum computers to the near absolute zero temperatures necessary to function, and this effort aims to address the most pressing challenges in the Department of the Air Force. The system funded by this grant will ultimately be integrated into an existing U.S. helium liquefaction plant, where it will extract helium-3 and return the purified helium to production with minimal disruption to plant operations. The Phase 2 effort will focus on prototyping and demonstrating the components at a pilot scale, as well as defining the physical, thermal, and operational interfaces that are required for eventual integration with the plant. Phase 3 will entail demonstrating the integrated system at an operational scale. Eventually, Interloon plans to extract helium-3 from the moon. And that wraps up today's Intel Briefing. I am joined now by Director of Enterprise Content Strategy here at N2K, Mayan Plout, to share the other stories included in today's selected reading section.
Thank you, Maria. We have 3 additional stories today. First, RTX's Collins Aerospace and the Goyle Netherlands Air and Space Force has established a new military avionics service center. Crossbow has completed installation of its additive manufacturing of solid propellant. They're completing initial operational testing of this patented production system at its Texas campus. And our third story is that BAE Systems has added new capabilities to its radiation-hardened 12-nanometer integrated circuits. As a reminder, links to all of those stories and original sources for everything we mentioned throughout this episode can be found on our website, space.n2k.com.
Hi, T-Minus listeners. Whether you are tuning into T-Minus for the very first time or the 500th, we want to know what you think of our show. So, yeah, friends, how are we doing? And you can tell us what you think with our listener survey. It only takes a few minutes to fill out, and you can rest assured that we will be poring over your feedback. Link to the survey is in our show's notes for you. You can find it in your podcast app. And thank you.
What's your 2 a.m. security worry? Is it, do I have the right controls in place? Maybe, are my vendors secure? Or the one that really keeps you up at night, how do I get out from under these old tools and manual processes? That's where Vanta comes in. Vanta automates the manual work so you can stop sweating over spreadsheets, chasing audit evidence, and filling out endless questionnaires. Their trust management platform continuously monitors your systems, centralizes your data, and simplifies your security at scale. And it fits right into your workflows, using AI to streamline evidence collection, flag risks, and keep your program audit ready, all the time. With Vanta, you get everything you need to move faster, scale confidently, and finally, get back to sleep. Get started at vanta.com/cyber. That's VANTA.com/cyber.
Our guest today is Derek Harris, Head of Business Development at Skyrora. And they've recently been awarded a new contract from ESA for 3D printing. And I asked Derek to tell me more about how that came about.
A few years ago, we were approached because we had made our own 3D printer. It can print over 2 meters by 2 meters, which allows us to 3D print our engines. It has a huge sort of base for that, but it also has a machining head on the same machine. So whereas old printer styles, you need to print, take it off, do your machining, put it back on to the exact millimeter, we can do everything without removing it. So this allowed us to be welcomed into a consortium called Made 3D, which is made up of some of the bigger players within Europe, so Siemens, Safran, things like this. And we have been the print partner of choice. So they will look at different projects. So one of the projects we're looking at is bimetallic printing, so taking copper onto Inconel. So that gives the heat resistance to the engine, means you don't need as much Inconel, so it's lighter, and a lot of good benefits for anyone trying to launch into space. So because of that, we've kind of got the reputation to go to for these sort of things when it comes to if you need to print something and are looking to do new or innovative alloys for that purpose. Skyrora seems to be the ones that people are coming to, and that's kind of what's happened by Metallysis and Thermocalc when we're talking about Cambium.
Beautiful segue there. This is the more recent Skyrora news with a number of partners that you just mentioned. So this also relates to an ESA project. So please do tell me a little bit more about that if you don't mind.
Yeah, so this has came in under what's called GSTP, and it's all about basically advancements that can be used within different sectors in space. And on this occasion, there was a new alloy being looked at, as I mentioned earlier, Cambium. And what this allows us to do is very, very similar to Inconel, which we currently use within that, but it's got better properties. It's got better heat resistant, it's lighter, and it can actually be cheaper once it's up and running, or at least that's what we hope for that. So Metallysis is helping to create this actual new alloy, and the whole program for us is very, very early steps towards full adoption. But what it means is we will produce what I like to call little nuggets. So they're roughly about the size of a credit card and somewhere between maybe 5 and 10 millimeter thick for that purpose. And then that allows us to do all the testing we need to start with on things like thermal properties, how brittle it is, and basically just all the testing you would expect to go through a normal metal, so that would be part of any sort of spacecraft. So it's very, very exciting to have been asked and to have joined with these companies, because we see this as a way of securing sort of sovereign launch as well going forward. We're seeing a huge amount in and around the world at the moment with people sort of looking at minerals, and we've seen the recent minerals deals that's been signed. All of this is highly important to make sure that the UK and Skyrora as such has access and the ability to continue launching and access for space.
Absolutely. And can you tell me a little bit about Tanbium?
So that's a very good question. So when we're talking about Tanbium, one of the largest indicators with it is it will have a much stronger tensile strength, while also providing heat resistance at a much better level than what Inconel currently does do. So when it comes to engines, it's going to be a very speciality alloy, perfect for the space industry. We've been using Inconel for many, many years in oil and gas, so it's been a while since we've had that sort of generational jump. So that's where the major benefits will come in from that. On the flip side, the actual being able to generate and bring this actual alloy to the marketplace, when we first look at where some of the key elements, when we talk about Inconel and where that was coming out of, we're looking at the coming out of some nations at the moment that are obviously in conflict around the world, or that we don't have the best geopolitical relationships with at all occasions. So your Russia, your China, things like this. So being able to bring through this new alloy, which, looking at the main differences here with this for that purpose, and when we look at the actual manufacturing, it's pretty novel. It's, I'll try and pronounce this correctly, hafnium-free, tantalum niobium alloy base. So what that means with this basically is that the main key information that we're looking to get from this is byproducts of zirconium, for example, which comes out of China, who does a lot of refining for major processing, but Brazil, who is actually quite a big partner with the US at the moment, for example. So being able to get these alloys and the individual elements between that much easier and from trusted allies is going to be huge. As I said, it takes away the scarcity value on the open market.
And also feeds back into the idea of greater space sovereignty from beginning to end. So not just the end result of sovereign launch, but also all the way back through the supply chain of sovereign and more trusted access. So that makes a great deal of sense. And I was thinking also the name tantalum and then niobium are in there, so you get tanbium. Okay. Light bulb moment.
That's it. When you look at the names of some of these things, it's like, I think I know what they are, but let's just have a double check. Let's look at the ingredients list, because you could be wrong, which is always the case for me. And it the minute I put something out wrong, I know the team will be on me in a heartbeat. So I have to make sure they're correct. But my major hope with this project is this is the starting point again. So I was asked recently by a student who was studying, and he's doing a report. He's saying, well, are we theoretically at the end of the jumps that we can do when it comes through to chemical propulsion? And I'm like, well, pretty much we're at the theoretical limits of those. So there's a bit of an issue there. So what can we do until then? I said, well, until we develop new novel ways of propulsion, or you've got electric, you've got nuclear, things like this, we kind of need to look at the materials we're using and how we can make things better. How can we do them stronger? And sort of, if we're talking sustainability point of view, we're talking from an environmental aspect, from an economical aspect, and obviously, as we were mentioning earlier, the geopolitical aspect with that as well. So I hope this is the first stage in a jump in some of the materials that we're now using within space. So imagine this, everything goes to plan and it's the full gold star from ESA. Yeah, you were completely correct, 100% on your homework. Your predictions in theory were right. And it prints so well and it's there. It replaces it. So there you go. That then can maybe and this is, just don't take this number as gospel, but this is, say it takes 10% of an engine weight. So you have nine engines, that's almost one full engine weight off your vehicle. It's huge sort of differences with this. And there's up and down the UK with some of the major universities we're looking at, they're all looking at advanced manufacturing techniques and things that we can do better. Not really aimed at space mostly, but other sectors, because obviously while the UK has done a huge amount of space, especially in and around satellites, we've always been sort of more dominant and innovative in other sectors. So seeing that technology now being turned back in their eyes on us, I think what you'll see over the next sort of 3 to 5 years is huge little gambles on different types of materials to be tested, because at the end of the day, it only costs a small amount of money with these grants to do the testing. But if you find a new alloy that can be used within space, the money that you can gain back, or the savings you can gain back, is just unbelievable for that purpose. So I think the programs similar to the GSTP, which ESA have run and allowed us to be funded for this project, are an absolute must. And it's one of the ways that the European Union and the UK can sort of try and catch back up to the US, since we abandoned especially around launch, we abandoned in the 70s again. So
I really look forward to seeing all the incredible advancements coming out of the UK and the EU over the next few years. It's going to be amazing to see. And it is amazing to see, frankly, going on right now. Is there an expected rough timeline for maybe when we'll hear the results of this effort? Or,
yeah.
Is there one?
I expect we're talking, from looking at the paperwork, we have to provide the full reports to ESA within about 8 to 12 months. So it'll be quite a quick turnaround on the first stage with that. And I think even before that will be finished, we'll have a sort of indication ourselves to how it's performing and such, and how it's printing. And if it's performing well, I'm sure the team and I will be sort of going back saying, okay, it's looking good. Can we go for something bigger? Can we maybe make one of the small engines and test fire out of the alloy and things like this? So I know everyone involved is really, really passionate to try and see where it can go. And as I said, we just have to take that step by step, and hopefully we'll be there to enjoy it. And the next time I come on, I can say about the success, and maybe even show you a video of us testing.
Oh my gosh, that would be amazing to see. Well, I wish you all the best of luck with this and great success. And Derek, is there anything else you wanted to add or leave our audience with before we head out today? I
think the biggest thing is, hopefully we've been pretty quiet for the last year or so while we've just been putting our head down and working hard to get our license and to aim towards launch. Hopefully next year I'll have a lot more fun that you can sit and watch. So everyone knows the fun part about rockets is watching the engines and watching things launch. So hopefully next year I'll have a lot more footage for you. So watch this space, and without the pun.
We'll be right back.
At Thales, they know cybersecurity can be tough and you can't protect everything. But with Thales, you can secure what matters most. With Thales's industry-leading platforms, you can protect critical applications, data, and identities, anywhere and at scale with the highest ROI. That's why the most trusted brands and largest banks, retailers, and healthcare companies in the world rely on Thales to protect what matters most: applications, data, and identity. That's Thales. THALES. Learn more at thalesgroup.com/cyber.
Welcome back. Some happy news has two teams just beaming today. A joint mission between the Chinese Academy of Sciences, or CAS, and ESA, or the European Space Agency, in fact, just passed its qualification and flight acceptance review and now has its launch window. And that mission is the Solar Wind Magnetosphere Ionosphere Link Explorer. And the acronym is, drumroll please, SMILE. No, that's not a directive from me. That is the name of the mission. It is SMILE, the name of the mission. SMILE, that mission SMILE. We'll be looking at sunbeams, sort of. Instrumentation aboard the SMILE mission include particle and magnetic field detectors, along with UV and X-ray cameras, and they will all be used to study how the Earth reacts to particle streams and radiation bursts from our local star. The goal of SMILE is to help humanity get a more complete understanding of the Sun-Earth connection by measuring solar wind and how it interacts with our magnetosphere. The launch window for the SMILE mission starts April 8th and goes to May 7th, 2026, and it will launch aboard a Vega C from Kourou, French Guiana, after it leaves its current testing site at ESTEC in the Netherlands, where it recently received its happy news of completing its assembly, integration, and testing phase. And understandably, when you look at the press release about this mission's news, the joint ESA-CAS teams were indeed all smiles. And that's T-Minus, brought to you by N2K Cyberwire. We'd love to know what you think of our podcast. Your feedback ensures we deliver the insights that keep you a step ahead in the rapidly changing space industry. If you like our show, please share a rating and review in your podcast app. Please also fill out the survey in the show notes or send an email to space@n2k.com. We are proud that N2K Cyberwire is part of the daily routine of the most influential leaders and operators in the public and private sector, from the Fortune 500 to many of the world's preeminent intelligence and law enforcement agencies. N2K helps space and cybersecurity professionals grow, learn, and stay informed. As the nexus for discovery and connection, we bring you the people, the technology, and the ideas shaping the future of secure innovation. Learn how at n2k.com. N2K's senior producer is Alice Carruth. Our producer is Liz Stokes. We are mixed by Elliot Peltzman and Trey Hester, with original music by Elliot Peltzman. Our executive producer is Jennifer Iben. Peter Kilpie is our publisher, and I am your host, Maria Varmazis. Thank you for listening. We'll see you tomorrow.
T-Minus.
Ever wished you could rebuild your network from scratch to make it more secure, scalable, and simple? Meet Meter, the company reimagining enterprise networking from the ground up. Meter builds full-stack, zero-trust networks, including hardware, firmware, and software, all designed to work seamlessly together. The result? Fast, reliable, and secure connectivity without the constant patching, vendor juggling, or hidden costs. From wired and wireless to routing, switching, firewalls, DNS security, and VPN, every layer is integrated and continuously protected in one unified platform. And since it's delivered as one predictable monthly service, you skip the heavy capital costs and endless upgrade cycles. Meter even buys back your old infrastructure to make switching effortless. Transform complexity into simplicity and give your team time to focus on what really matters, helping your business and customers thrive. Learn more and book your demo at meter.com/cyberwire. That's METER.com/cyberwire.